Here's my analysis of the analogy between Barbosa and Liouville and Tesla's special generator. First off, my electrician friend from Packwood, Washington, his co-worker over a decade ago, did not come up with a solid-state version of Tesla's special generator. That was my presumption, and I'm wrong. All I know is, the facts are, it was a notebook-sized shaped project box. Being notebook-sized, it always made me wonder, well, why was it in the shape of a notebook? And it's because it had a rotating aluminum disc. Powered by what, I don't know, but the purpose of that aluminum disc is fulfilled by the neon bulb. In other words, somehow the aluminum disc or the aluminum reciprocating piston that I postulated was in the Nazi U-boat, because all William Lyne said was that it was a reciprocating piston. He never said it was aluminum, but in a roundabout way he kind of implied it by saying that the mechanical watt-hour meter was similar in design characteristics, just a watered-down version, not quite the same thing as Tesla's special generator. In some way, a reciprocating aluminum, a moving aluminum body, let's put it that way, whether it reciprocates or spins, whether it's a homopolar disc or a reciprocating piston, doesn't make a whole lot of difference. What seems to matter is that there's electrostatics involved and it's just disruptive. And it's the equivalent of a disruptive discharge of a spark gap, which is what this neon bulb represents. So this qualifies as the aluminum piece in Tesla's tri-metal generator. The electric keeper qualifies as the copper, because that's generally what we use for wiring, although that makes me wonder why not use silver instead of copper. So Tesla's tri-metal generator does not have to be aluminum, does not have to be copper. And in today's materials, it doesn't even have to be an iron version of ferrite, because the earth is the common ground, and there are a lot of substances that can be magnetizable that are even more powerful than iron. But maybe power is not what's needed. Ferrite, actually, now that I think of it, the sun is a calcium ferrite material, the surface of the sun. The sun is a planet. There are a lot of different types of ferrites. So I don't know if anything can substitute for iron necessarily for the magnetic keeper down in here, in this area here. But that's what I'm getting out of analysis, that Tesla's special generator, the three metals are simply symbolic. But Mr. Dortz Jr.'s explanation to William Lyne is not adequate by saying that aluminum is reflective and copper is active and iron is ferromagnetic. The iron part is the only thing that's obvious. Active. Alright, so we need something that's active. Well, this is an electric keeper of sorts. And the activity in this loop is what's going to keep this going, apparently, but we have to keep it active, and that must be what the ground is for. While the input from plug number 2 is merely to set up a signature. Signature of activity. But this disruption up here must reflect back in to the activity that's in the core here, in this electric keeper. And the common ground of the earth is what's represented by the iron, not necessarily these transformer toroidal shapes, cores. That would be a distraction, I think, because they're actually part of this electric keeper as it is. So something else could substitute for this. So maybe the iron is in here. See, I don't understand this part fully. I only know that common ground of a very massive. Anyway, I can only go so far with this analogy. But that's what the neon. The main culprit here was, where's the aluminum? There's no need for aluminum in the circuits. So these are merely symbols that are functional. They represent functions, and so the aluminum is reflectivity, and so there's some feature to this neon bulb that reflects back in here, and it's probably the radiant energy that's being reflected back in, but transfigured in the form of disruption. So what's being reflected back is disruption. That's actually what's being reflected back. And disruption is an interesting thing. We think control is everything, but sometimes disruption comes in handy because it creates asymmetry. And that's an opportunity to liberate free energy, provided we're prepared to know what to do with it. So this keeper, which is electromagnetic, there's the electric keeper here, and then there's the magnetic keeper. So to make an electromagnetic keeper, it's actually copper and iron in combination. And then we have extra iron to add to the system, otherwise there'd be nothing over unity about this situation. Well, not necessarily. If we took this out, but kept this here, I bet it would be a minuscule over unity to barely offset some of the inefficiency. Certainly not enough to have a COP of 1, but to offset the inefficiency. So because there are losses, right? Resistance alone is a loss. So this is going to start overriding the losses, and this simply magnifies it. Magnifies the benefit of this reflectivity. Because remember, we're going into earth ground, which does incorporate a lot of clay, which, contains aluminum. So it may be that this sets up the initial condition for this to liberate, which means I really wonder if this has to be iron for common ground. It could be any mass of metal. It could be aluminum. I don't know. Maybe aluminum would be more efficient. Or maybe a, what do you call it? Amalgam. Not an amalgam. What do you call it when you blend metals? Oh, darn it. I'm short of words. A blend. Okay, a metallic blend. An alloy. Maybe if this were an iron-aluminum alloy, it would be more efficient. It's a possibility. Maybe. But instead of an aluminum rotating disc or a reciprocating piston, we get our disruption out of this spark gap. There might have been a very good reason not to have a spark gap on board the Nazi U-boat, and that is because of the liquid air on board, which, I don't know if that's an explosion hazard, and so you can't afford to have sparks. That might have been the purpose of the aluminum, is to avoid sparking. Here we have it contained in a neon bulb. I don't think this existed in Tesla's day, although he had vacuum tubes. But there might be a quality of the neon gas that has to be utilized to substitute for aluminum. So it's conceivable that a mere spark gap alone would not qualify as a substitute for the neon bulb. And that might explain the U-boat situation, might explain why he did not use a spark gap. I just contradicted myself, didn't I? Well, I ignored the postulate that neon had some special quality. Well, it's a noble gas, which means it's got a certain amount of rock-solid stability to it, so that in the face of disruption, it still has an orderliness to it. So there might be something about this that is advantageous over the mere use of aluminum, or kinetic aluminum, I should say. Aluminum set in motion, actually. It's not aluminum alone. So this is why there has to be the presumption that there's no such thing as a solid-state Tesla trimetal generator. But this is. You would think. I mean, it certainly looks that way. But we don't know how to make this independent of the Earth, to make it a common ground. I suspect this can be turned into common ground, but I'm not sure if I know enough to presume how that would happen. I just know a little to suggest, but I'm not certain I know enough to make it work. It's just an idea to detach this circuit from the Earth and make it mobile. So maybe this does have to be aluminum and not iron. I could be wrong. Maybe this does not have to be iron. Why should I assume just because the Earth is magnetic that this has to be iron as a common ground piece? I don't know what to assume. Let's put it that way. I don't know. Oh. Tesla had two metal rods he pushed in that were served like buttons to engage his device in his demonstration of his 1931 Pierce Arrow car. What if those two metal rods were aluminum and they replaced the neon bulb? Which means they're an air capacitor of sorts, maybe, since they're closely spaced. That would make it solid state. Unless the rotation of the electric motor in the Pierce Arrow had something to do with the operation of this device. It was an AC motor, and that would qualify as a substitute for the sine wave inverter. So it may be that this has to be an AC system, and one way or another you make sure it is, whether you use John Bedini's Tesla switch, or any of his other switching circuits to make it AC. But that might be another feature of this, is that it has to be AC. It cannot be DC. My friend who spoke of his coworker didn't say, and I didn't ask, whether it was an AC motor or a DC motor that was powered by his notebook-sized trimetal generator. It could just as easily have been a requirement that it would have been an AC motor that was being powered by that generator. So what his coworker might have done is replicate the Pierce Arrow demonstration. It's quite possible. Maybe if you don't have an AC system but a DC system, then you have to have a reciprocating piston. Not to make it AC, but to add an element of kinetics into the situation, because AC is kind of like a kinetic situation, while DC is kind of passive, because nothing changes, right? It's a different type of disruption. It's not chaotic disruption, it's orderly disruption, or else it wouldn't be a sine wave. So there are a lot of elements to this, obviously. It's a lot more complicated than just a few principles that can be qualified by just 3 metals. It's obviously, there's more to it than that. And that's why trying to understand this mystery is so difficult, is because it may not be that simple. And usually free energy devices never are. Usually they're slightly complicated, which is why it's so easy for replication to come up empty-handed. Attempts at replication. Okay, I'm going to leave it at this.